Okay, we're finding the missing number. Number 1, x equals what? X equals what, Savannah?
24.
What about number 2? 4/14 is equivalent to x over 35. What is x in number 2? Reagan? 10. 10 over 35. 8/36 is equivalent to x over 90. What is x? 20. 12/3 is equivalent to what, Miss Page?
28.
28 over 7. 20/14 is equivalent to x over 56. Darton,
80.
x equals 80. And finally, 18/4 is equal to x over 18. What's that going to be, Michaela? 81. Does everybody agree with all these calculations?
Yes.
And everybody knows how to get them? It's easy now that we've done it a while. Okay? Talking about scale drawings. And this is going to be extremely important to you with the project coming up. A scale drawing is a proportional, two-dimensional drawing of an object. The project that we're going to be doing, one of the first things you're going to have to do is determine what the object is going to be, what your project is going to be, and then you're going to have to get the original measurements. And then you're going to have to create a scale drawing on paper, on graph paper. Okay? So you're going to be working with that scale. Then you're going to create a scale model that is proportional, and a scale model is three-dimensional. It's a three-dimensional model of the object. Okay? I will tell you, I've had people go and get baseball fields. Not a good project. Because thinking about it, is a baseball field in itself three-dimensional?
No.
No, it's flat. The only thing that's three-dimensional is the bases, but they're so small that when you try to build a scale model, it doesn't work well. Now, if you were doing a scale model of the dugout, perfectly fine. Because, you think about it, it's a three-dimensional thing. Okay? So be thinking of that when you make your choices, okay, kiddos? All right. The scale is the measurements in the scale drawings and models are proportional to the measurements of the actual object. The scale gives a ratio that compares the measurements of a drawing or the model to the actual measurements. It's nothing more than comparing two quantities. Okay? We've done a lot of it all year long. Not just right now. Do you need something, ma'am?
I just was gonna brag on them real quick. I just finished grading their quizzes, and no one in here made below a C on their quiz
Woo!
today. So
Yay.
very,
They are rocking the test the last 2
Yeah.
days.
very, very proud of 7th grade. So nice job, guys.
There you go, guys.
Wow, good job.
All right. So let's look at this. If on a drawing, if 1 inch represents 10 miles in the actual thing, where do you might see drawings, and you don't see them so much nowadays because we don't see our parents get them out, but where do you see a drawing that might have mileage and stuff on it?
A highway, maybe even like a bridge or some other
A map.
it could be even like a map or like an entire town layout.
Okay. Often, now you guys don't see it as much. Back when I traveled with my parents, when we were going places, they drug out a map and they had this big foldable thing and they'd stop alongside the road and open it up and try to figure out what was going on. Mom might, now Dad would never. Because Dad didn't use maps. He didn't need maps, he knew what he was doing.
And then they get lost.
And then they get lost, and yes, exactly. But a map is definitely, has to be done to scale, okay? In social studies, do you see that in social studies when you're dealing with the geography of the countries that you've been studying? Okay? Same thing. Those things are drawn to scale because they want it to make sense to you. Okay? All right, so the drawing size, the distance, and then the actual distance. That's what we're comparing, okay? This would be a page you want to keep track of, all right? Let's go to here. Find the actual dimensions of the scale. If the scale is 1 cm centimeter equals 4 feet. So if 1 centimeter equals 4 feet, I need to know how much is 7 centimeters. 7 centimeters is going to be how many feet? Well, that's really my x, isn't it? And can I solve for the x?
Yes.
What's it going to be, Savannah? So 1 centimeter equals, or 7 centimeters equals 28 feet in real life. Okay? That's pretty simple stuff. So if I have 10.5 centimeters on my model, oops, wait a minute. Sorry. Number 2, what is the length in real life? What is its length in real life?
42 feet.
42 feet. 10 centimeters on 0.5 on the model is 42 feet in real life, or actual dimensions. A lot of times I've noticed kids on their notes, they're just putting the answer, but they have no idea in the notes how that was gotten. And so later on, when they get down to sit down to have to do the work on their own, they have no idea what we did to get it. So I'm telling you on your notes, if all you're doing is writing the final answer, that's not going to be real helpful to you. So make sure you write down how we set the two ratios up or the proportions up. Okay? Number 3, if on the model I have 30 centimeters, what is it in the actual setup? What is it actually? What's it going to be, Kennedy? 120 feet? Everybody agree with her?
Yep.
Okay. Tell me how to set the next one up, Mr. Caden.
Put 1/4,
Mm-hmm.
and then 19 over x.
Ah. Now look at that.
It's millimeters.
Look at this one.
X over
Can I convert, or can I stick with the 19 millimeters over x to find out my feet? Why not? Because the scale is what?
Centimeters.
Centimeters. Can you convert 19 millimeters to centimeters? Yes, how? How do I convert the millimeters to centimeters? So I gotta convert first. How do I do that, Miss Michaela? Ten. So I've gotta back it up then, don't I? Good. I've gotta back my decimal to 1.9 centimeters. Now I can set it up 1 to 4 equals 1.9 over x. And so what is the actual distance? What is my actual distance, Mr. Cooper?
7.6
7.6 feet. Reason for it, look here, 1 centimeter to 4 feet.
I just have one.
Okay? What about number 5? Number 5, what do I have to do? I gotta convert, don't I? Because that's meters, isn't it? And I need centimeters. Think about, Kathy has devoured my delicious candy M&Ms. If I'm at meters and I've got to go to centimeters, I'm multiplying it by how much?
2.
It's not 2.
20.
It's not 20. Convert equivalence. 1 meter equals 100 centimeters. So I've got to multiply 0.4 times 100, or move my decimal over 1/2. And that's what you were talking about too, wasn't it, Mr. Gabriel? I got to move the decimal over 2 places, so that's actually 40 centimeters. So I have 1 to 4 equals 40 over x. What's the actual distance? What's its distance? 160 what? Go back up to the scale. Feet, okay? Okay? Same thing here. I've got how many centimeters? 4 25/100ths of a meter is how many centimeters? How many centimeters? How many? 425. Good job. So I have 1 centimeter is 4 feet. 425 centimeters equals how many feet? How many feet is 425 centimeters, John? 1,700 feet. Okay? You're going to have to be able to do this, because you're going to definitely do it on this project a couple of times. Going from the original, because see, the project has you taking the big down to the itty bitty, the drawing, and then up to the model. See what I'm saying? What is the actual distance between distance between Cadillac and Detroit? Cadillac and Detroit. Notice the scale. What is the scale?
1 to 50 miles.
Notice the way the scale is written. On your models and on your drawings, you're going to have to be able to write the scale. So pay attention to how do we write the scale. Scale of map. Pay attention to that. Okay? Make sure you know how to write it. That's going to be some of your points. What is the distance between, the actual distance between Cadillac and Detroit? Well, I've got 1 centimeter equals 50 miles. Have you used the ruler to measure that distance? And you want to make sure you're measuring in centimeters and not in inches. Because my scale is in centimeters, not inches. What did you guys get when you measured?
3 and 2/10 is what I got.
I got a 3 and 2/10.
What do you get?
I got
3 and 2/10.
3 2/10 is what most people are getting. So if I have 3 2/10 centimeters, what's the actual distance between Cadillac and Detroit? What is its actual distance? Jillian, did you get it? How much? 160 miles. Is that what you all got? Okay. Now, by looking at this, does it look like 160 miles? Of course not. It doesn't. But you can tell on this, I don't even see where there's Cadillac. I see it. Oh, and Detroit coming across. So it's approximately, it's getting pretty close to, you know, you could you figure out your distance across, all the way across that city, or that, what is that, Detroit, Michigan? Could you figure out your distance across Michigan if you wanted to? Sure you could, okay? You got the same type of thing. The scale again, always look at your scale. Your scale tells you how to measure. Always check the scale out before you start. Make sure you're using the right measuring tools before you measure. If you measure it in inches and try to convert, it's not going to give you a proper conversion. How much? 3.5? Okay, I'm hearing that they're getting 3.5 centimeters.
I got a 2.9.
Yeah.
And then, okay, hang on a minute, and that has to, what did we say, our scale was 1 centimeter to 50 miles. All right, so what are we getting? I got a 3.5, I got some with 2.9. How many of you got 2.9? Okay, if you got 3.5, take a look at it then. So this has to be 2.9. What is the actual distance between Traverse City and Marquette? Traverse City to Marquette. What's its actual distance? What did you get, Keenan? 145 miles. Do we agree? Making sense, ladies and gents? You know what? I'm going to do you a favor because I think, how many of you would say, fist to 5 right now? I can measure and I can convert, and I feel pretty good about it. Fist to 5, show me where you're at. So that if I allow you the rest of the time to practice on your assignment, do you think you would be successful? Okay? I'll visit with you. All right, let's go to here. Here's your assignment. I want you to begin looking or thinking about an object you would like to create a model of. Okay? But then the assignment that you're going to turn in will, on Monday, you're going to bring it with you on Monday, is the math journal page 164 and the textbook page 305, 32 to 36. Pardon? It didn't.
Mrs. Risha, next week is our second to last week of school.
This year,
That's nice.
the day this is due is 3 days.
It's 3 days before school's out. Yep.
And the last 3 days we have to play around?
Last day of school.
Okay. When you're thinking about these projects, think about, can I go and measure them? Can I get some measurements on them? If it's a project that you are using, maybe you could actually do a project from the internet if you wanted to. But you've got to be able to actually grab the measurements so that you can convert, okay? So, you know, honestly, I'm going to tell you, like a car is really hard to do because I'm not saying you can't, but getting the shapes and the curves and the tires and that gets pretty tough. So I don't want you to go out. It could be your bedroom. It could be your living room. It could be your classroom. It could be, you see what I'm saying? You don't have to go and get, like, yeah, I'm going to do the Eiffel Tower, or I'm going to do, I had somebody do Twin Towers once,
That would be cool.
okay? And you'll get more about it, but think about things that is actually going to be doable for you. And, you know, I want them to be good projects, and I want you to have fun with them. I don't want them to be too easy, but yet at the same time, I don't want you guys to stress yourself out so much. This is a fun way to end our